CERN's next accelerator, the High-Luminosity LHC, has the goal of increasing the number of particle collisions in the collider to generate more data for physics discoveries. A cornerstone of this upgrade is the string of innovative magnets and their associated systems that will sit either side of the collision points of the ATLAS and CMS experiments. A challenge here is that a very high current needs to be transferred without losses between the power converters at room temperature in the new High-Lumi LHC underground galleries and the magnets at the extremely cold temperatures needed to keep them superconducting. This is where the innovative cold powering systems come in. Each system consists of a boiler-like device called the DF and a room temperature connector called the DFH, joined together by a snake-like flexible link called the Superconducting Link. 8 of these will be installed, 2 for each set of magnets on both sides of the ATLAS and CMS collision points. To keep the magnets cold, they are submerged in superfluid helium, which is as cold as deep outer space. The boiler cryostat is fed with liquid helium and boils it to a gas which flows through the superconducting link, cooling it over its full length. The helium's temperature increases as it absorbs the static heat of the link and flows out through the connector cryostat in the upper gallery. As it flows through the connector, the helium's temperature increases sharply to room temperature and goes on to be processed through a gas management system to be reused in the machine. The so-called resistive parts are made of copper, which transfers current from room temperature cables to cables made of REBCO tape in the connector. REBCO is known as a high temperature superconductor as it stays superconductive at relatively high temperatures compared to standard superconductors. This means that the REBCO cables efficiently transfer current across the sharp temperature change to the Magnesium Diboride cables of the superconducting link without dissipating energy and heat. Magnesium diboride is a special, flexible material that allows more efficient current transmission compared to conventional superconductors, as it operates at higher temperatures that mean gaseous instead of liquid helium can be used to keep it cool. It can carry up to 100,000 amps of current in its compact volume, all the way to the boiler in the LHC tunnel. This is the amount of electricity used for about 25,000 people to blow dry their hair. A connection module links the boiler to the magnet chain, allowing the magnets to be powered. This cold powering system is one of the many innovations developed for High-Lumi LHC, which is being used for the first time ever in an accelerator.